The final component of our lab is on a double displacement. You're going to be reacting solutions of sodium hydrogen carbonate with hydrochloric acid. Again, this is a qualitative, so think about observations. That is not precisely being measured, but it's talking about more observations. You'll be asked to make those careful observations. Keep in mind you're being a chemical detective. What kind of observations can you make to let you know a chemical change took place? Was this endo or exothermic, as I spoke to in the last instructional review video? We're going to be reacting sodium hydrogen carbonate. We're going to have to write out its formula. Sodium with its +1. Hydrogen carbonate, sometimes we call that bicarbonate, HCO3 -1. And hydrochloric acid. Now there's a hint there that says this is a kind of a double replacement followed by a decomposition, because I know I can see that there's 3 products. So the double displacement, Na and the H are the positive ions. They're in exchange places, aren't they? And by the way, the NaHCO3 starts aqueous as well. So aqueous and aqueous. NaHCO3, so the outer switch and then the hydrogen, and no, I didn't connect that right really for what I wanted to do. Erase. Sodium is going to hook to the chloride, hydrogen to the hydrogen carbonate. So one of my products will be NaCl. And then I'll write HCO3. But then I understand that I'm not done, because that's not 3 products as it has told me. NaCl remains aqueous, sodium chloride is water soluble, but this carbonic acid breaks down further. I mean, as soon as it's formed, it's so unstable it will start to see carbon dioxide bubbling out and a water molecule being left in solution. So technically, the 3 products, H2CO3 is gone as soon as it's made, and I get NaCl, aqueous, plus CO2 gas, plus H2O liquid. The driving force, we've always been instructed to circle our driving force, are the bubbles that we see of carbon dioxide. Turning all of those into a series of words, creating a sentence, NaHCO3. I'm going to start that by just writing out aqueous sodium hydroxide. Then I see the plus sign, so I go reacts with. Then I see HCl, aqueous. Aqueous hydrochloric acid is redundant because we know acids are always in water. So I'm just going to write hydrochloric acid. Then I have the arrow, which means to form, produces, yields. Last time I'll write to form. Aqueous sodium chloride. Then that next and. Then I have, let me get rid of that pop-up. And then I have CO2 as a gas, so I'll write gaseous carbon dioxide. And then the plus sign, so that's the word and. And then I see H2O liquid, so I'll just write water. It's not ice, it's not steam, it's in the liquid form, so I'll call it water. Aqueous sodium hydroxide reacts with hydrochloric acid, forming aqueous sodium chloride, gaseous carbon dioxide, and water. Remember, think about 2 observations, and one of them is going to ask you about heat. Was it exo or was it endothermic? And be able to support your reason. You won't get credit just for guessing. You have to tell me how you knew, providing evidence of your change. Now, here's one double replacement. Wash that test tube clean and onward we go. Here's a second separate reaction under the double displacement category. So we'll be adding aqueous potassium iodide with aqueous lead-2 nitrate, making careful observations because this is a qualitative exercise. So starting with aqueous potassium iodide, we'll start that with lead 2 nitrate. So here are my two reactants written in either order, both in the aqueous form. Keep in mind the pattern of double displacement. Potassium goes to nitrate, lead will go to iodide. Remember the charges as you're considering the products. When I go back and form potassium nitrate, +1 -1, so I just have KNO3. And Pb goes to I2, but Pb is the one that's a positive 2 charge, so we get PbI2. Identify the driving force. You're going to see a precipitate in this reaction. The solid floaties that you make end up to be a pretty yellow color. The yellow solid is the insoluble product on our solubility table. Therefore, I must include the aqueous on the potassium nitrate. Excuse me. And I have to include the solid as my adjective for my precipitate. Circled your driving force. And then, of course, you're going to be asked to turn those into words for the question we wrote above. So I'm going to just put mine down here so I can actually see my equation. I'll extend the page and write a sentence. So I have aqueous potassium iodide reacting with aqueous lead 2 nitrate then the arrow, so I'll put forming, producing, yields, lots of choices there that are nice. And then we have aqueous potassium nitrate, right here, the potassium nitrate. Then I have a plus, so I'm going to write the word and then PbI2, don't forget the Roman numeral, lead, Roman numeral 2, iodide, solid. That is the driving force. Was it endothermic or exothermic? What evidence of change did you note as you were playing a chemical detective? Now the lab practical, 4 parts. Part A and Part B are both quantitative. Measurements matter. Accuracy will be part of your grade. Part C and Part D are qualitative. It's all about observations, being a chemical detective, being able to write those balanced equations. So think about precision in your measurements for the combo and the decomp. Think about playing chemical detective in the single and the double replacements. And I have every confidence you have an A++ coming on your lab practical.